Yeah, so I'm Wang from UC Berkeley, and today I'm going to talk about our work about how to make privacy regulation compliance easier. So this is a joint work between University of California, Berkeley and the University of Vermont. So I see some of my excellent collaborators out there in the audience. I especially want to thank them for their help on the project. So some background. So privacy regulation has become a trend. So most of the regions in today's world has either crafted their own privacy regulations or has started to draft one. So for example, the European Union has a general data protection regulation. And in US, in California, we have California Privacy Rights Act and California Consumer Privacy Act. And Canada, China, Brazil all has their own privacy regulations. And we also have specific privacy regulations for certain domains. For example, we have HIPAA for healthcare data, and we have FERPA for educational data. So although privacy regulation have brought us a lot of benefits, privacy regulation enforcement is actually costly. So according to the Information Technology and Innovation Foundation, the California's privacy law will cost $78 billion annually in total, and California's economy will bear $46 billion out of it, and the rest of the US economy will bear the other $32 billion. And what makes things worse is small businesses will bear a non-negligible portion of it. So California small businesses will bear $9 billion of it, and the out-of-state small businesses will face $6 billion of the cost. And this will severely impede innovation and success of small startups. So why is policy enforcement so costly? Let's check out today's enforcement pipeline. Okay. So data collector, like large companies or public organizations, they will collect data from the data owners and usually their users. And this collected data is, of course, protected by some privacy regulation. So when the analyst employed by the data collector wants to conduct some kind of analysis on this data, they need to submit the analysis details to the privacy officer. And privacy officer usually is an employee of the data collector. And their responsibility is to make sure all the data analysis happening within the data collector complies with correct privacy regulations. And the reason why this pipeline is so costly is because hiring and training privacy officers is very expensive because the skill set required to become a privacy officer is pretty unique and complicated. So you need to understand the details of the privacy regulations, and you also need to understand the basics of data analysis. So our idea is pretty straightforward. So we want to design a system that can facilitate privacy officers in their daily work, so the cost of training and hiring a privacy officer will be reduced. And we name our system PrivGuard. So here is a toy example how PrivGuard works. So at first, the data privacy officers will translate the privacy regulations into some machine-readable format, which we refer to as the base policy. And for example, here, the data privacy officer translates a regulation saying that minor information should be removed from your data set before the analysis is conducted. And then the data is collected from the users. And the users can specify their own privacy preferences, which is some additional privacy requirements beyond the base policy. For example, the user here can say, I don't want my zip code to be disclosed to any analysis. And then when the analyst wants to conduct the analysis on the collected data, they need to submit two things. They need to submit an analysis program, and they also need to submit something called a guard policy. So guard policy is a description of the privacy requirements satisfied by the program. And it is written by the data analyst, so it can be wrong. So the program here says that it does two things. It first imports a data processing library called pandas, and then it filters out all the minor information using the indexing function of the data frame. So the analysts say in their guard policy that my program satisfies this privacy requirement, that all the minor information has already been removed. And then the guard policy, the privacy preferences, and the program will be given to a component called PrivAnalyzer. So PrivAnalyzer is a partial replacement of privacy officer. It will automatically decide whether the program actually satisfies the base policy or not. And if the program passes the check, then it will be fed to an execution engine, and together with the data, and the result will be returned to the analyst. Otherwise, it will be rejected. And we also integrate two security components, a key manager and the trusted execution environment to protect the confidentiality and integrity of the data and the execution process. So attentive audits might have found that we have a lot of different policy encodings in our system. So let's check how we encode them and how they interact to enforce the regulation. So first, to encode this thing in a machine-readable format, we need a policy encoding language, and we choose legalese from Sen et al.'s well-cited paper. And we have three different encodings in our system. We have base policy, which is a direct translation of the privacy regulations written by the privacy officers. And we have a guard policy, which is the analyst's description of the privacy level satisfied by their analysis program. And we also have privacy preferences written by the users. It's basically their additional privacy requirements beyond the base policy. So we need to do three checks to make sure the program satisfies the base policy. So first, the guard policy should not be less strict than the base policy. Because if it is less strict, then the analyst's description of the program is already weaker than the base policy. There is basically no way it will actually satisfy the base policy, unless there are some mistakes in the guard policy. So we will directly reject it. And if it passes the check, then the guard policy will be used as a filter condition to filter all the data whose owner's privacy preferences are weaker or equal to the guard policy. So in other words, we only pick those data whose privacy preferences are not so strong that we can use them and not violate the privacy preferences. So these two steps can be done by a simple comparison between policies. And unfortunately, legalese intrinsically support comparison between policies. But in the last step, we need to verify that the analyst doesn't lie about the privacy level of their own program. So they don't say something not true in their guard policy. And this requires us to compare a program with a policy. And it is not trivial like how we can do this. And to address the challenge, we designed a static analyzer called PrivAnalyzer. So PrivAnalyzer is a static analyzer based on abstract interpretation framework, and it supports formal soundness proof. And its functionality is that it can automatically check whether a program satisfies a given privacy policy. So here is a simple example how it works. So let's take the program and the policy from the example in the previous slides. So the program does two things, like I mentioned. It imports the data processing library pandas, and it uses the data frames indexing function to filter out all the minor information. And the policy has two requirements. First, all the minor information should be removed. And second, all the zip code should be redacted before analysis. So inside the PrivAnalyzer, the first thing we do is we will replace the data analysis library with a stub version, which we refer to as function summaries. So inside these function summaries, we re-implement all the functions in the data analysis library with the same name, the same argument list. The only difference is that instead of taking in real data frame, we take in objects representing policies. And the functionality of these functions is to remove the privacy requirements satisfied by the corresponding data processing function. For example, here, the indexing function together with the filter condition will satisfy the first requirement. So it will be removed. But the second requirement is never satisfied, so it will be output as is. And because there is still a remaining policy in the output, we know that not all the requirements are satisfied, so the program will be rejected. So we evaluate our system, and there are two takeaways from the evaluation results. The first is the overhead of PrepGuard is small compared to the original system running time. And the second is the overhead comprises two parts. The first part is the overhead of running PrivAnalyzer, which does not grow with the number of users you have, because it's just one comparison between a program and a policy. And the second part is when you use the guard policy as a filter to pick out those data whose privacy preferences are weaker than the guard policy. And this part of overhead grows linearly with the number of users because the more users you have, the more privacy preferences you need to compare with. And this will conclude my talk. Thanks for listening. And for contact information and to download the full paper, you can scan the QR code there. And I'm glad to take any question.